I have a question, sir.
Yes.
Why is it like sometimes, yeah, the attendance taker doesn't join the class in some lessons?
They're not taking attendance every lesson. They
Oh,
take randomly.
oh, okay, okay. All right, all right.
Okay. Okay, let's start. So we are up to the question 7, right? 7. We finished this. And did we finish this also? I forgot. Anyone can remind me? Do we finish this yet?
No, sir.
No, sir, right? Good. Because I mixed up with the CMI class. You're having the same question paper. I think almost 80% are the same.
Sir, what's the highest mark for their class?
The highest mark for them is 79 out of 84.
Oh,
They got
wow.
4 more marks because they have one more topic. And for
84 out of
MP,
84?
they got 30 out of 33.
Wow.
Wow. Okay lah. There are 4 of them, 3 really outstanding. They got almost 90 something marks in total.
Sir, did you
Okay.
leak the paper?
No, I didn't. They usually got high marks.
So how much they pay you? Be
Altså,
honest.
gamerne er paman. Yan
Oh,
chase
I don't.
Sir, they said that they pay you 10,000 for a A.
Corruption.
No, no corruption.
Sir, the Chinese friends say they pay for A. It
Okay,
means
let's continue. Let's
10,000.
continue. Only one lesson today. I try to finish at least 10 questions. I hope. So Stanley kicked the ball, and the ball goes straight with initial velocity 9. So you need to get this value, u 9, and it experiences deceleration equal to 4. So that means A should be equal to -4. Decelerating should be a negative value for acceleration. How long the ball will move? So it will stop when the final velocity becomes 0 and you're looking for the displacement. This is an easy question because you just need to get the value from the questions and put it into the suitable equation. So that's why you should make use of this equation. U squared equal to U squared plus 2AS, right? So at the end is 0. So that's why you may put 9 squared equal to how long? Oh, sorry, see Mr. Love fooling around. How long is looking for the time is not the displacement. Okay, my bad. Let's continue. Let's do again. So we may use another equation. V equal to U plus AT. So V is 0, U is 9, and plus -4 times T. So you may find out the time T. So that's 4T equal to 9. I move this to the left-hand side. So T is equal to 9 over 4, which is 2.25. So B for boy. All right, so easy question. Next question. Oh, so Rob, you're late. The attendance TA just left. Oh, no response. Okay, number 9. I'm just kidding. No worry, huh? And a ball is being released from west, and it comes down, right? And hit the ground, bouncing back again and again like that. So since it's being released from a certain height, so you see that the velocity is increasing, it's getting faster, but the direction is downward. You can see that the value of V is larger. So that's why this part is falling down. It's falling down. Then surely this part is talking about bouncing. And after this point is still on the ground. But the velocity is the largest. I mean the speed is largest. It is far away from this 0. and gradually it slow down. When the ball leaves the ground upward, it would be having the fast speed and then getting slower, slower, slower up to this point. So at this point, what is happening is maximum height. I think we talked about that in the revision class, right? So make sure that you know how to read this graph step by step, and especially the direction. Above that, it is downward. Below that is upward. Okay, now see the question. First, we take downward x positive. So you may check this. Downward x positive. So this is correct. Number 2, P represents the instant the ball reaches the highest point. Not really. Highest point is at Q. You know, highest point means originally it go upward and then it changed from upward to downward. So that means at the transition from negative value to positive value, it would become the maximum point. Okay, so I may highlight all the points. It should be this point. Maximum height, maximum height, maximum height. Is okay? And the third one is Q represents the instant the ball hits the ground. So Q, as I told before, it should be the maximum height. This point, these parts, are so messy. I use highlighter. These parts, these parts, these parts. The speed change, the velocity change, direction, suddenly, and with a big value leaving the ground. So that's why only the vertical part would be talking about the ball hitting the ground. Okay, so let's continue. Next question. Oh, the answer is 1 and 1 only. 8. Okay, next. All right. The question 10. The question 10 talked about a tow truck try to move the car with a cable, and they are moving at constant velocity. So we must be very sensitive to these wordings. Constant velocity, immediately you should link up with net force equal to 0, right? So net force equal to 0, so we may consider the car, it should be having 2 forces acting on it. One is the tension from the cable pulling the car forward. My car looked like a submarine. And then, since net force is 0, that means it has to be a force going backward to balancing the pulling force. So what is the force? This force is on the rough level. So it should be a friction there. So that's F minus F equal to 0, the net force. But now the cable suddenly break. So what will happen? If the cable suddenly break, there would be only one force existing. Like this force is no longer existing. So the net force would not become F minus F anymore. It would become only negative F, and it would not be equal to 0 in MA. So in that case, the car originally moving in constant velocity, right, according to the question, it will be under the influence of the friction and decelerating and come to the rest. So you may have a look. It stopped immediately. It's wrong. It takes time, right? It moves at constant velocity. It's also wrong because it has friction to slow it down. And the third one, this one, is also wrong. It moves in opposite direction. It's not possible. Do you ever see a car suddenly move in opposite direction by the friction? It's not possible. So the answer should be only B. It will slow down, decelerating, and come to rest due to the friction. Cursed car. Wow. Goals. Okay, now so answer is B for boy. We are making use of net force UMA. Or Newton first and second law to answer that. All right. Okay, next question. Next question. There's a wakeboard. Oh, sorry. A man of mass 70 kg is riding a wakeboard, and there's a pulling force 100 Newton pulling him forward. And there's a friction on the water surface. It's 60 Newton. So what is the magnitude of acceleration? So easy lah. Free body diagram. Okay. There's a pulling force 100 Newton. And there's a friction backward. So by looking at these two forces, we should be able to write this F net equal to 100 minus F. So there's only two forces along its moving direction. So that's why it should be equal to MA. Right? So you may just put the number in. 100 minus 60 equal to 70A, which means 40 equal to 70A. So that A is 40 divided by 70. Okay, so answer should be B for boy. No, sorry, C. It's A. Let's calculate by calculator. Yes, it's A. Okay. It's okay, right? So next one, 12. Okay. This question, I talked about that in the revision class. Which of the following pairs are the action-reaction pair according to the Newton's third law? So remember, the definition for Newton's third law is it involves two objects. A provide a action force, F, to B. At the same time, B would be also providing a reaction force back to A. So notice the wordings. It involves subject, object, and you interchange the subject and object to become the reaction force. And these two forces has a relationship. They should have the same value, but with opposite direction. So that's why you see a negative sign here that represents the opposite direction. Okay, now you see all the pairs here. It looks like all pairs are having the opposite direction. And they also like balancing each other. They have the same value, but are they action-reaction pair? The key is whether it involves object, subject, object, and interchanging it. So you notice that the force acting on the ball, this is B, by the player. That means the player provides a force to the ball. So the corresponding reaction force should be the ball giving a force to the player. But now, this FB is the weight of the ball, is from the earth to the ball. So they are not really interchanging the subject-object thing, so this is wrong. Similarly, for the second one, tension in the string that holds the object. That means this is the string providing a force to the object. So I call this is A, this is B. The reaction force would be the object giving a force to the string, right? But now, it's again the weight of the object is from the earth. So they are not action-reaction pair. But the third one is the force on plane by the gas. That means gas providing a force to the plane. And the other one is opposite. It's just opposite. The plane provides a force to the gas. So you can see the subject-object interchanging. So that's why they are action-reaction pair. All right, so be aware of this action-reaction pair involving two objects providing a force on each other. Each other, this one is the key for the Newton's third law. So answer is 3 only, 3 only, okay? Okay, next question. Yeah, again, I talked about this in the revision class. If a bullet hit the wall with initial speed 330, and after passing through the wall, the speed becomes only 208. So what is the average resistive force? Now, since the bullet is horizontally moving, after it penetrates a barrier, the speed becomes slower. So in this process, there's a change in KE. This change in KE should be equal to the work done against the resistive force inside this block, this wall. So it should be F times thickness, work done, force times displacement. So you may find out the change in the KE first is half 0.005 times 208 square minus, use the final KE minus the initial KE, which is equal to force times 10 cm. Now, you may do it wrong if you don't correct the unit from gram to kg. If you don't correct this by using centimeter into meter. So we have to use standard unit because it involves the change of the unit from force, distance, and this and that to become joule. Whenever you use, we apply equations, we always use standard unit. Okay, kg for mass, ms-1 for the speed, and then meter for the distance. So you may calculate this and find the answer. Okay. So I don't spend time on calculating that. You may do it on your own later on. But the method is simply using change of KE equal to work done against the resistive force. Okay. So answer, I forgot the answer already. You may check with your answer paper. And 14. This question, it has a car of mass 1150 kg. It breaks down on the level road, and the engine is restart after the car is being pushed for a 5-meter distance, and the speed becomes 1 meter per second. Okay, so let me erase the board first. I need more space to do this. So when you push the car, it should be having an initial velocity 0. And after displacement 5 meters, the final velocity will become 1. So if now the resistive force is 100 Newton, what is the work done by the driver to restart the engine? Now, this work done by the driver should be equal to the gain of energy by the car. What energy the car actually gain is KE. It gains speed, but it don't gain any potential energy because it's a level road. There's no PE gain, so that's why the work is going to the KE plus some energy is lost by the work done against friction. Okay, let's check if you understand what I'm writing on the board. The work provided by the driver will be partially become the KE of the car and partially used to overcome the work done against friction. So you may add these together. Half m, oh sorry, I should put the value there directly. Times 1150 times 1 square. This is the KE. And then I need to find out the friction is 100. And the distance traveled is 5. Okay, then you may add them together. This one is simply equal to 1150 divided by 2, 575. And on this side is 500. So altogether, we got 1,000, sorry, I should not use this. 1,075 joule. This is the energy provided by the driver. He pushes the car. So you can only pick this answer, 1,800 1080. I think the answer has round off to 3 significant figures, so that's why you pick this. D would be the only answer that is suitable. Okay. Do you notice these? The question give you other options like 500. 500 is this. 575 is this part. It's a bit tricky. If you forgot any one of the, if you only include one of that, you may get the B or C. How about A? A is the subtraction of it. If you do subtraction of that, sometimes the sign would mix. You may mix the sign up and did something wrong. But like this one, if you do minus, it will become 75. So each answer is a misleading answer that would be coming from your misconception, right? So that's why it's a good question. Okay, next. Okay, there's duck. A duck is rest in a pond, and this photograph shows the image of it. You may just imagine the water surface is a plane mirror, and the nature of image are as follows. First, it is laterally inverted. Right? And secondly, you may say that it has the same size and it has the same distance from the water surface. So it's also a virtual image because the light the image is behind the water. It's not possible to use the screen to project that. So that's why it's a virtual image. So number one is correct. The image size is the same, as large as the object, same size, right? It's also correct. The image is located at the surface of water. It's not really correct. If the object is something like a person, and this is the plane mirror, the image should be behind the mirror with the same distance. This is the image. There's no way that would appear on the mirror. So that's why the third one is wrong. Answer is 1 and 2. Okay. Next, this question, you have to be careful. I know one of Ferris Mark's classmates did wrong by careless mistakes, so upset. So by right angle, I know this is 60. And according to the law of reflection, I know this is also 60. Together with this right triangle, I mean this one, this angle should be 30 degrees. And you're looking for the final reflected angle of reflection. So that means you're looking for this angle. It's also 30 degrees. Okay, so actually it's easy. 30 degrees is A. A. Well done. Now let's continue. Okay, next. We got 3 settings of the periscope. Okay, and this periscope is make use of prism. That means it is going to use total internal reflection for the reflection. So if we want to know whether the image form is upright or inverted, so we have to draw the ray diagram. So we are looking for the inverted image. So just do this. Okay, the one on the top will be reflected like this, and the one at the bottom will be. So you notice that the red one is the tip, and the blue one is the tail. So that's the final image. It's upright, it's not upside down, so 1 is wrong. Okay, do the same thing on the second one. Okay, and for the lower one, is it okay upside down? So that this one, the image is like this. We see the head is at the bottom. Okay, so 2 is correct. Okay, you may have a look on the third one too. Similarly, we do the same thing. I just put the light ray. Looks more complicated, but it's still the same method. Like this. Okay, is it upside down? It's not upside down. It's still pointing upward. Okay, so answer is 2 only. Easy, easy. If you know the method, it's just like you draw, you get the correct answer. Okay, for the next one. There is a light ray sent from medium X to medium Y, and the refractive index of Y is larger. That means NY is larger than NX. So if the refractive index is larger, that means the speed should be smaller. And so does the angle will be also smaller for Y. So now, whenever you do a question like that, you have to draw the normal line to help. It has an angle here. In medium X, you should be having a larger angle according to our deduction here. So D at theta X in X medium is larger. So that means the light ray would bend towards normal. So that's why it's B, towards normal. You get a smaller angle. So that's the answer. B for boy. It's okay? All right. This is a difficult question. Question 19. We try to estimate the focal length of the lens. To do this, there are different methods, but I myself would highlight one thing. If the question only gives you one light ray, I think the only thing you can do is to extend this light ray first. That means you try to extend this light ray backward. So I'm doing that because we know that this should be a concave lens. It's diverging. It's diverging, so that is a concave lens. And the image should be virtual. Whenever we find the virtual image, we try to extend the light ray being reflected. Okay, we got one light ray, but how about the other one? The other one you may draw is, let me draw like this. You may use this as the object, okay? And then you draw the light ray pointing to the center, optical center. If this is the object, I will draw a light ray passing through this. So this is the intersection, and there should be the image somewhere here. You see that? It's not really clear enough. This is the position of the image because these two light rays intersecting at this point. So that's why it's the image. We didn't get the answer yet because the question is asking for the focal length, but we always know that parallel light ray would be going to the focus. So that is the parallel light ray. And it will come from the image also. So we join these together. This parallel light ray will be coming from focus. We don't know focus, but we have image. We join image to the lens and extend the line. So this intersecting point would be the focal length. This intersecting point would be the focal length. It would be 8 cm. All right. So I think it's time's up. So we will stop here up to now. Tomorrow we have double lesson, so I guess we'll finish these MC questions and or maybe some more long questions. Any question to now? No response. Okay. So yeah. Now, don't leave this exam paper. Just you need to really spend time on revising that, especially the questions you did wrong, especially some topic you are not really familiar with. It's just like a mirror for you to review on how you look like. And we need to find ways to improve, right? There's only 1 year and maybe 2 or 3 months for you to prepare the DSE. It's important for us to spend more time to do better preparation. So get ready. So let's continue tomorrow. Okay, bye-bye. Bye-bye.
Bye, sir. Thank you.
Okay.
Bye, sir.
Bye-bye. Pedro, Rosemary, are you two sleeping?
Oh, bye, sir.
Oh, bye-bye.
I wasn't sleeping
Hello.
last, sir. I wanna stay here, ma.
Okay lah, you look so happy. What happened?
Huh?
No.
Okay lah, what lesson now?
What lesson now?
Oh, you don't
LS.
even know that. LS. Okay, get ready. I go back to my office. Bye-bye.
Bye bye, sir.